Okay, cool. Yo, what's up? What's up? What's up? My name is Menace, short for Menas Lunga. This is gonna be the last study stream for Grad Algos. Grad Algos, that's my real accent. My bad, my bad. Cool, so let's start with some motivation for the stream. I do not really need to give the exam tomorrow. I've already cleared the exam with a pretty decent grade. I don't need to work on my GPA. I don't need to keep my GPA up and so on. My GPA is also pretty solid. It's like a 3.88, 3.9 if I get an A. Uh, and let's see what else. What else is there? Yeah, in general, there is very little motivation or incentive to give tomorrow's exam, and everything is in place. I graduate next Friday. Not next, dude. I actually graduate this Saturday. My bad. I walk. I do the commencement walk this Saturday, and yeah, and then I move to Seattle. Uh, 2 weeks after that, and yeah, I start making some big bucks, I guess. But the point is, tomorrow's exam has very little incentive, right? Like, why should a man study for an exam that doesn't matter? I'm doing this purely out of principle, but also uh, there is another gain in a function that I'm looking forward to, and that is testing out my willpower. Uh, I generally do not have troubles with studying, but it's only towards the end of any exam or towards the end of any um, task that my mind starts playing tricks on itself. It's like, hey, there is no need to keep going. You can just stop now. And that's what I want to fix. That's what I do not like. It's like when you're on a treadmill and the entire uh, 15, 18 minutes of the treadmill session will not make you think, will not fatigue you, but the last 2 minutes, that's when you are aware that okay, the end is near, and that's when you feel the most fatigued. That's the same thing with exams and the study here, because there is an element of exam attached to this subject. I am compelled to, uh, not compelled, there is this hard wiring in me that forces me to, okay, there is, okay, let me rephrase it. Because there is an exam that I have to give tomorrow, that's why I am somewhat stressed. There is no reason to be stressed. Somewhat stressed, however, and I should technically not be stressed. I do not want to have this element of stress. I do not want to be the person who performs or does an act purely out of uh, purely to reap purely because he expects some reward. That's not something that I want to do. I just want to maximize the number of hours. It's like hour maxing, like uh, that's something that I want to fix. Let's see. It's gonna be a tough session. uh, I have zero expectations tomorrow. uh, I just want to do my duty. I want to stay committed to my goals. I'm a very principled man, and I'm very uncompromising on my principles. Like, I do not like to uh, yeah, it just won't feel right if I do not give my best. I'm honestly, if I'm being very honest, I'm not giving my best right now because there's just an array of psychological mental tricks. I do not punish myself for it. I acknowledge it, but I want to keep going. I want to keep grinding. And yeah, I think in this stream, I'll again cover the rest of the exam material. Also, let's also talk about how the exam is going to be an opportunity for me to be experimental with the way I study. Uh, I perhaps do not need to mug up things, or I do not need to memorize a lot of facts. I already have a cheat sheet, but in general, I do not like to rely on cheat sheets. I tend to memorize everything, and the only thing that I do trust the most is my memory. So, anyways, I think I'll try to trust a cheat sheet this time. I'll try to see what is the core teaching of the remainder of my lesson, and then I'll just move on to solving sample tests. And yeah, I think that's all that there is to this, I guess, and we'll see how it goes. Man, and yeah, I think there are going to be a few ground rules to this, right? Let me write down the ground rules. Uh, Ground rules, cool. Hold on, maybe I can. Or let's see, guiding principles to study. Or okay, this is also not an accurate heading. Experiments to perform. One. So we have to be very brave, and we have to be very experimental with today's study and see how it goes. Right. One. Do not mug up any fact. Purely rely on cheat sheet. That's one. Purely rely on a cheat sheet. Take short breaks and develop interest in the study material. This is very crucial. Like, if you do not develop any interest in the study material, you won't be fully immersed. You won't enter a flow state. Have fun. Yeah, like the thing is, I'm currently clearly gonna find it extremely hard to enter flow state because there is very little reason or interest in studying. But life is of life is literally like this, right? Like, you will be presented with scenarios where you are supposed to do things that you do not give a shit about, right? And what does a man do then? Like, it's your duty to perform your best, honestly. Uh, 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 Predict what you will be tested on. Um, that's one more, and then yeah, I think these are good enough, I guess. Okay. Take micro naps, maybe. Stay hydrated. Yeah, I think this should be good enough. Cool. So, man, I misspelled hydrated. Cool. This is what we're gonna try to focus on today. This is what we have. So we have to go through 19. Okay, so let me open up all the PDFs that I need to go through now. Because we'll just start. We don't have to go through a lot of them anyways. We just have to go through 6 of them. And 6 PDFs, very tiny PDFs. These are like not very massive PDFs in any way. So let's see what this is. Not this. Okay. This is 19, this is 20. Copy link. This is 21. Right. Okay. This is 21. This is 22, I believe. Wait, hold on. Why does this look same? No, this is not same. Okay. And hold on. Which one did I open just now? 22 is what is open here. Let's see. Now we want to open 23. Online algorithms. And maybe okay. These are pretty big, I would say, but the handwriting makes it look that like it's super big, but it's honestly like a very tiny amount of stuff to go through. Sure, there are some PDFs that are pretty big, and sure, we'll go through these. No worries. I guess that's just life. It's okay. Okay. Cool, man. I'm having a protein bar. It's so good. So good. Okay. So I'll go here. Finish going through. Okay, and don't try to mug up facts. Try to deeply understand and jump straight to predicting what can be asked in And so we know that there's going to be 120 mark question on this. And beyond that, should be pretty straightforward. Okay. Okay, this is nice. Yeah, pretty good. Okay. Interesting. Just going through some tweets before I jump into the studying part. Introducing Willow, our new state-of-the-art quantum computing chip, with a breakthrough that can reduce errors exponentially as we scale up using more qubits. Cracking a 30-year-old challenge in the field. In benchmark tests, Willow solved a standard computation in less than 5 minutes that would take a leading supercomputer over 10 to the power 25 years, far beyond the age of universe. Crazy, okay. Hartmut Naven, okay. Let's see, this guy looks interesting. Wow, this guy's pretty cool, not gonna lie. What's this guy posting? That's so cool. Hmm. That's okay. What are these feature posts, dog? Okay. Okay. Okay, interesting. I'm just trying to figure it out. Hmm. Hmm. Okay, that's pretty good. Sure, I guess. Okay. Sure. Just trying to understand Google's blog. The quantum ship. Let's see.
The systems behind our universe are quantum mechanical. They shift and change with the problems they're tasked to solve, exploring a vast array of options all at once. And like nature, quantum computing is responsive to the environments it works within, leading us to new breakthroughs for tomorrow's most challenging problems. Introducing our latest quantum computing chip, developed to learn and evolve like the natural world around us. Willow, from Google Quantum AI.
Hi, I'm Julian Kelly, Director of Hardware at Google Quantum AI. And today, on behalf of our amazing team, I'm proud to announce Willow. Willow is Google's newest and most powerful superconducting quantum computing chip, and the next step in our path towards building large-scale quantum computers and exploring their applications. I've been fascinated with quantum computing since I first experimented with qubits in 2008. And since coming to Google in 2015, it has been a dream to make our mission a reality, building quantum computers for otherwise unsolvable problems. We launched our first chip, Foxtail, in 2017, followed by Bristlecone in 2018, and Sycamore in 2019, which powered our milestone 1, the first quantum computer to surpass the best classical supercomputer on a computational task, random circuit sampling. Over the years with Sycamore, we have been able to squeeze a remarkable amount of performance from our hardware, including achieving a scalable logical qubit in our milestone 2. But we've ultimately been limited by quantum coherence times, the length of time qubits maintain their intended state. With Willow, we've made a huge step forward. We've increased quantum coherence times by a factor of 5, going from 20 microseconds in Sycamore to 100 microseconds in Willow. And we've accomplished this all without sacrificing any of the features that made our systems so successful. This advancement was enabled by our new dedicated superconducting quantum chip fabrication facility in Santa Barbara, one of only a few in the world. And we're seeing exciting developments coming from Willow, which has already surpassed Sycamore's breakthrough demonstrations. Our logical qubits now operate below the critical quantum error correction threshold, a long sought-after goal for the quantum computing field since the theory was discovered in the 90s. And we've achieved it for the first time with Willow. Errors are exponentially suppressed in our logical qubits, as error rates are halved each time we add physical qubits and scale from distance 3 to 5 to 7 surface codes. Additionally, our logical qubit lifetimes are now much longer than all of the lifetimes of the physical qubits that compose them. This means that even as we make our quantum chips larger and more complex by adding more qubits, we can use quantum error correction to actually improve their accuracy. We've pitted Willow against one of the world's most powerful supercomputers with the random circuit sampling benchmark. The results are pretty surprising. By our best estimates, a calculation that takes Willow under 5 minutes would take the fastest supercomputer 10 to the 25 years. That's a 1 with 25 zeros following it, or a timescale way longer than the age of the universe. This result highlights the exponentially growing gap between classical and quantum computation for certain applications. Let's talk about the hardware approach we've pioneered at Google Quantum AI that makes these things possible. Our tunable qubits and couplers enable super fast gates and operations to achieve low error rates, reconfigurability to optimize hardware in situ and run multiple applications, and high connectivity to efficiently express algorithms. We leverage this tunability to enable reproducible high performance across the device. Let me explain. A challenge in superconducting qubits is that not all of them are created equal. Some are outliers with uncharacteristically high errors. But here's where our tunable qubits really shine. We're able to fix these outlier qubits by reconfiguring them to perform in line with the rest of the device. And we can go one step further by having our researchers use tunability to continuously develop new calibration strategies that push errors down across all qubits with software. Let's quantify this and nerd out for a minute on quantum computer tech specs. We have number of qubits. Connectivity is the average number of interactions each qubit can perform with its neighbors. We quantify error probabilities for running simultaneous operations, how many computations we can run per second. And application performance is a full system. system benchmark. Willow hits a sweet spot across the full list. It has a large number of qubits with high connectivity and can run diverse applications. We measure low mean error rates across all operations with multiple native 2-qubit gates. We have greatly increased T1 times. We have very high measurement rates, and Willow is below the error correction threshold and performs.
In 2019, Google made quantum computing history. Our quantum computer completed a benchmark computation in 200 seconds that would have taken the world's fastest supercomputer at the time 10,000 years. In 2024, Google reran the experiment on our latest chip, Willow, and saw a significant leap forward. We got Hartmut Neven and Sergio Boixo together with theoretical physicist John Preskill to talk about what this means.
Since we introduced the benchmark in 2019, we keep running it every year, and the times it would take for a classical supercomputer to emulate or to simulate the latest benchmarks that we can run on our quantum processors has grown tremendously.
It grew from 10,000 years in 2019 to 10 to the power of 25 years, or in words, 10 septillion years on the Willow chip. This illustrates the double exponential growth in compute power.
There's an interesting aspect to the superiority of the quantum computer. The Google hardware has improved a lot in recent years, as we've been hearing, but it still makes lots of mistakes. So they have to run it many times in order to extract a usable signal that can be compared with that classical simulation. They in fact run it millions of times. But they can do that in just a few minutes, which is still a very short time compared to the resources you would need to do the same simulation on a classical machine.
John popularized it with the name quantum supremacy at the time. At Google, we tend to call it beyond classical computation, but it's all just the same idea. It's trying to make true experimentally for the first time the promise of quantum computing. We have
Not do either. The next challenge
On Hans and
extended experimental
compared to, say,
from other groups as well have improved even faster.
part of what's significant compared to, say, 5 years ago is now we can.
The computational cost increases exponentially with the number of qubits or of the
That's
in the, yeah.
to not, I've said this before, king of
And this guy is.
I see now. Okay, sure. That is something, I guess. Interesting. Interesting. Hmm. Hmm. Interesting. ठीक है, this is so cool. Hmm. Interesting. Interesting. Very interesting, bro. Okay. Radiko. I get it, dog. Okay. Got it, dog. Got it, dog. Okay. No one's watching. And that's exactly when you gotta work the hardest. That's what life is all about, I guess. You know, radical. Hmm. Very interesting. Just wanna quickly show something to y'all while I'm on the stream. There's this guy called Luigi Mangione. I don't know if I'm understanding this right. Uh, this is so interesting though. Let's see. 7 years ago, I gave my high school senior speech on this topic. Today, I'll be talking to you about the future, about topics ranging from conscious artificial intelligence to human immortality, like you'll dismiss. But it's just science fiction. Okay. Man. Oh my god, people are already tattooing him? That's an icon, not gonna lie, dog. Let's see. Yeah, they're definitely creating a story about him. That's crazy. Hmm. Very interesting person, honestly. Hmm. Okay. Interesting. Hmm. That's it. That can't be right, to be honest. Interesting. Interesting. I guess that's just how life is, huh? Crazy that people are like stalking him. Interesting. Mm-hmm. Very disturbing, honestly. Okay, cool. Let's go here. Interesting. Sure. Hmm. No, please stop this. Okay. Okay. Let's test it. I'm just surprised that it doesn't think it's. What the sigma, bro? Mm, well, it's not as good as. I mean, it's okay, I guess. Not the best. I think this is the issue with Meta AI as well. Like, there's something that it's not able to do right. Interesting. This is close, maybe, but still not good enough. Bro, come on, bro. Stop doing that, dog. Hmm. Interesting. somewhat okay, I would say. And I don't even know what's the limit on this. Like, do they say that, hey, that's all you can do, or not good enough, honestly? Yeah, it's okay, I guess. We just gotta see. Interesting. Interesting. Okay, this is like a hard thing to do. It typically, like, it's hard to render such a detailed thing. But okay, good for them, I guess. Okay, let's see. Wait, why am I able to use Grok then? Huh. This is interesting because I'm able to use Grok for some reason. Okay, I guess that's... Okay, whatever. Whatever, bro. No, don't do that, please. Don't do that, Rogue. Let's see. Okay. So, let me open up my sheet right here. Okay, bro. Okay, bro. Okay, bro. So, let's see. Where was I? Okay, so PDF 19 I'm gonna go through, but I also want to check out the resources. What problem sets were given for this thing? 7 is one. I know 6 was on gradient descent. I know 7 is this. Is problem set 8 the last problem set? Let's see. Okay, problem set 8 is actually the last problem set, and 7 was just a reduction. So 7 is actually pretty straightforward. It's just a reduction. So, and I know that typically exams will have content that is very closely mirrored to problems that you get in assignment. So problem set 8, which I have open over here. Let me just open up the solution to problem set 8 because that's gonna be what's gonna be asked. So I'll just make this here. So I know that the problem set 8 is gonna be one of the probably going to be enough for me to cover if I want to like go through decidability and randomization and so on. So anyways, let's see OV problem. There's a search and verify thing here. Okay, so I know search is simply actually finding the solution, verifying if a solution is correct, and sure, this part is pretty straightforward. This is similar to P versus NP. So P is the set of problems that can be solved in polynomial time. NP is set of problems that can be verified in polynomial time. Okay, so there's the fundamental difference. The fundamental difference is P is solve for, okay, so P is search, NP is verifiability. So P is search, NP is verifying, okay? And we assuming that P is not NP, there must be a problem in NP, not in P. There must be a problem that we can verify solutions in polynomial time, but we cannot find solutions in polynomial time. Okay, can verify in polynomial but not find. Okay, fair. I see what we are trying to get at. Right, that's pretty good, pretty good. Okay. Is there a connection between P, NP and OV? Okay. Sure. So I'm just trying to understand the structure of every node. Like what is important in this node? I would just say the search, verify, P and NP is important. This is just some statement. What we are trying to build towards is the connection between P versus NP and OV. Okay. So we define like something NP hard. A problem A is NP hard if every problem B belongs to NP. That is, a problem B can be verified in polynomial time and can be reduced to A in polynomial time. Okay, so okay. Okay, so B is, we know B can be verified in polynomial time, and we are saying it can be reduced to A in polytime. Okay, sure. If A is NP hard and assume we can solve A in polytime, then every problem B, okay, this would be, this is what P equals NP would mean. Like this particular section here is just saying, okay, this is what you would need to declare P is equal to NP. Okay, a problem is NP hard if every problem B belongs to NP. Okay, you belong P, belong to NP. Okay. And okay, so there is something happening internally where I'm like, okay, hold on. What am I thinking of? I'm thinking of, okay, in this particular section, I'm trying to question if I understand a particular section of the page, right? So I understand it, but I have this tendency to reread it, right? What did I just read? I read that if an algorithm A is NP hard, then an NP problem can be reduced to A in polytime. Okay, so NP hard. NP hard. Okay, what is an NP hard problem? Every problem B in NP. Okay, so let's just say I'm just gonna be like content for the final cheat sheet. Okay, I'm just gonna be like, okay, content for the final cheat sheet. Okay, I will just say final cheat sheet content. Not that I need it honestly, but sure, right? Or I could also add it to my Anki flashcards maybe. Grad Algos 2. I'll just add NP hard problem A. Explain problem. Okay. A problem. Okay. Problem A is NP hard if every problem B in NP can be reduced to A in polynomial time. Okay, sure. And set. Cool. So that's one added. Let's go here now. So this we understood, and we understood why, when can we say P is equal to NP if we find any if we find any problem in B that can be also solved in polynomial time, then it means that it can also be reduced in polynomial time and solved in polynomial time, total meaning that we are able to solve it in polynomial time. Okay. Oh no, it's the other way around. If you assume we can solve A in polytime, then B belongs to NP can be solved in polytime. Okay, sure, I guess. If P belongs to NP is what they're saying. Okay. Okay, I think I get it. Okay, so we are saying that B is non-polynomial time solvable. B can be verified in polynomial time, and if you are saying A can be solved in polynomial time, and we already know that A can be reduced to B in polynomial time. Oh wait, this is the other way around. B can be reduced to A, right? So let's see if I got it right. Uh, was it in this one, bro? Okay. So okay, I see. B is reduced to A. So we are saying A can be done in. Oh, I get it now. Okay, I get it now. I get it for sure now. Cook-Levin theorem. This talks about the KSAT NP hard problem. K greater than equal to 3. Okay. So there's the Cook-Levin theorem that we need to figure out. So let's see if we can just figure out from the text. KSAT is an NP hard for K greater than 3. Okay. Input is a Boolean formula in conjunctive normal form. Okay, so you have ORs and ANDs. Okay, there could be a not in between, sure. Clause. In KSAT, each clause has k possible negated variables. This is one clause, and one clause can have 3 negated variables. Okay, so just gonna write this down. So x1 or x2 or x3 and clause num vars in a clause is k. Okay, find the assignment of variables such that phi, this thing symbol evaluates to true. Okay, so we got to figure out the assignment of variables. Okay, fine. And there could be several of these, okay? Okay, so assuming P not equal to NP, we can find a solution in... Okay, finding a solution is hard, but verifying it, okay. Hamiltonian path. SAT can be reduced to Hamiltonian path, okay? If Hamiltonian path has polytime line algorithm, if Hamiltonian path has polytime line algorithm, then SAT has polytime algorithm, sure. Okay, so SAT reduced to Ham path, that we know. Okay, got it. There are multiple conjectures about the hardness of KSAT. They give lower bounds. They give different lower bounds. There's a conjecture which says P not equal to NP. No polytime algorithm possible is what it says. Exponential time hypothesis says that KSAT needs 2 delta to the power 2 to the power delta to the power n time for some constant. Example, okay, so it takes some exponential time. And okay, so there's an exponential time hypothesis which says that it takes some 2 to the power something time for some constant dou greater than 0. And strong exponential time hypothesis set says no faster algorithm than 2 to the power n, which is interesting again. Okay, so the only thing, okay, so exponential time hypothesis says that 2 power dou power n for some dou greater than 0, and set is just saying it's 2 power n, doesn't talk anything about doesn't talk anything about dou or something. For all epsilon, there exists a case such that KSAT cannot be solved in... Okay, I see. Interesting. So there's this time complexity for KSAT, which is like KSAT is 2 1 by big O of 1 by k to the power n. Okay. Set says for large values of k, we cannot do substantially better than brute forcing all to the power n variable assignments. Okay. OV says for large D, we cannot do substantially better than brute forcing all to the n square pairs. Okay. So this is n square and this is 2 to the power n. This is a bit different, right? Okay, so one could say that assuming set, there is no algorithm for solving OV conjecture. Okay. So there's a reduction that is taking KSAT to OV. Okay. Idea is that there is a sub-quadratic time for algorithm for OV. Then there is a sub-exponential time algorithm for KSAT. Okay. Okay, so basically we're saying that we are trying to solve KSAT with OV. Reduce A to B bole to use B to solve A, right? So split every clause C into CL and CR, C right and left, okay? CL uses half the variables, C right uses half the variables. Okay, you use half variables in the both place. For every assignment, in the first half, you construct a vector Vy. You construct a vector Vy if CL is true for y, 1 otherwise. What is CL though? Clause? Does that mean clause? No. CL is just the right and left splits, okay. For every assignment Z of the next half, constructing U. Oh, okay. So we are using this formula, this reduction, to construct a. Okay, so this is like a reduction that we could be asked, right? Okay. What the fuck is this dog? Yo, what the Sigma dog? Crazy dog. It's crazy dog. Okay, I get it now. Oh, I see now. Nice, okay. Nice. MD. Okay, cool. Okay, I see now how it works. I get it. You stay there, dog. So I see. So in order to reduce KSAT to OV, what is the input to KSAT? KSAT ka input is like a bunch of variables, like some K variables and some clauses, right? You will have like some N clauses, right? And okay, you split every clause C into the left clause and the right clause, okay? And out of these clauses, you construct your vectors v and u. So v banane ke liye you'll do, okay, so I should perhaps just like note down the reduction, because that could just be asked, like there could be a problem modeled around this and I could just be required to understand the reduction, and I could just like write down the reduction and get some bonus points, because I don't want to like go too deep into the theory. But sure, say there is a reduction that is happening here. Do I need to understand the idea of the reduction, right? I'm just saying you construct Vy, and okay, you're saying that if the clause is true, then you make it 0, otherwise 1. If the clause is true, 1. Okay, for every assignment Z. Sure, every assignment, as in like you can just create multiple assignments, right? Like there will be way too many assignments of these, fine. And if makes sense, I see how you are reducing this, but this reduction might, I do not know the time complexity for the reduction, right? Sure, I get it. I get how they're splitting it. I see the reduction. So the term complexity number of vectors is 2 to the power n by 2 variable assignments, dimensions d. So I see now this is how it's happening, which violates set, right? For any constant k, this is, oh okay, I see now. This says key, okay, this says that there is some way, and set don't like that. Do it. Set don't like that, dog. Dude, actually PDF 19 was very easy. PDF 19 was very easy, right? And what I could do is, as I go through this, I could just start noting things down, like, because this was very trivial, right? Yeah, sure, debugging halting is not too hard, honestly. This just uses Rice theorem. Previous one uses like Cook-Levin's theorem, I guess. This is just like 4-page shit. This is like 7-page, and this is super huge. And the thing is, randomized algorithms are super easy because the exam pattern is just gonna be linearity of expectation and union bounds. So maybe some questions on these things. You may have quick sort, for example, as an input. Sure. Yeah, this is gonna be a bit, I think 21 is gonna be a bit difficult. 19 and 20 are very trivial. 21, 22, and 23. Yeah, there could be question on online algorithms, maybe, but let's see. So I'm thinking, yeah, I could just do that, I guess. Ah, my God, bro. Let's do that. Honestly, let's do that, dogs. So on this new result, this is not a cheat sheet, so I'm not gonna keep this with me right now. These are all my cheat sheets, so I'll just keep these around with me. But this one, this paper, I will just use this. Match it with the size of my simplex cheat sheet. Ouch, this is kind of torn here, but that's why we can always use it from the other way, right? Yeah, this is perfect, honestly. Okay, just prepare in my cheat sheet. Cheat sheets are allowed, by the way. These are legal and recommended by every class. Just an FYI. Yeah, I'm okay with this. Okay, I'll move this to this side, I guess. Now, okay, this is done. This is done. I'll just like create this, make it trash, like throw it in the trash can. Trash can's pretty far away, but let's see. Ah, didn't work out, but that's fine. There was nothing on this, honestly. It's fine, girl. Yeah, that's how it's done, boy. जलवा फैशन कहे ये जलवा आनाता नो Skibidi George Bush. Just 9, okay. Alright, let's do it. So, the simplest way of this bothers me. This bothers me a lot. This is not a good fold. Honestly, we'll try this. The problem with this fold is this is perfectly aligned, and this should be perfectly aligned, right? And then in the same vein, if this is perfectly aligned, no, so these, you see, this should be aligned like this, I guess. But this is not what I wanted, did I? There is some fold that's not very well aligned. That's my problem. This is the fold that's not well aligned. Maybe this, and you see this part is a bit weird, right? This is almost as good as it gets, I guess, right? I think so. This is as good as a fold can get, I believe. And now perfectly creasing this, because now we gotta bend it the other way around, right? Yeah. 'Cause now that we bend it the other way around, perfect. Now we bend this one the other way around. Perfect. This is my fourth cheat sheet. So I believe we are allowed to get like. Let's go to Q&A actually. Okay. No real emphasis on after exam 3. What? Lectures till November 20th will be on the exam. Okay, lectures till November 20th. Let's see. This was November 5th. This does not have a date. Sad. November 7th, 5th. Let's see. November 7th and 5th. Then, if this is 20th, then according to my calendar, this was 20th. So 12th was 21st, 22nd, 23rd, which is okay. 23rd. So okay, so basically all the PDFs that are uploaded will be there. But they said that there is no real emphasis on after exam 3. No real emphasis on after exam 3, but one long question will be from the after exam 3 syllabus. The rest 2 long questions are from syllabus till exam 3, which is good, which is really good, right? Which is awesome. Let's say thanks right now. So now this cheat sheet for final exam. Okay. Example 1 per unit, of course. Two-sided. Okay, perfect. So can bring 4 sheets. Beautiful, beautiful, beautiful. Top 21 problems are used. The ungraded problems, okay, and that's dropped. So if you decide to skip the current, Sure. So cool. Perfect. 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 There's no real emphasis on exam after exam 3. So there's no real emphasis on content after exam 3 is what we have been told, which is really good, honestly. Yeah. There's one long question. So I believe the one long question will be very similar to what we saw in our so okay, pretty good, I guess. Not bad, honestly. Not bad. One 48 minus 135. Just 13 more people. Okay. So there's no real emphasis on content after 3. Fine, that's fine though. We'll still go through it. Right. Baby, what you try to do to me? Baby, Atavania. Okay, so let's do this, right? Let's keep this to the side for a minute and let's do search versus verify. I'm on my second protein bar right now. Actually, third protein bar of the day. I'm low-key, I suspect this is not good for my health, having so many protein bars in a day, but you know. Oh my god, this is so good, bro. Okay. So search is just finding an orthogonal pair. Okay. Okay. Finding the verifying if a given solution is right. Okay. And then there was and how it maps to P equals set of problems solved in this is just search. Set of all problems that we can verify. Okay. Verify in polytime. This is just verify because इसके name में भी verify ही है, so this should be easier to remember, I believe. Now let's go ahead. NP hard. Right. Problem A is NP hard. Okay, I know this already. Every problem B that belongs to NP can be reduced to A in polynomial time. Right? A general assumption is we're using A to solve B in this case, is what we're saying. Okay, cool. और हम बोल रहे थे कि A can be solved in polynomial time is what we know. We know A can be solved in polynomial time, and we are claiming that if A can be reduced, okay, B is the NP problem, which we know can be verified in NP, and we are saying we are trying to reduce B to A, and then B to A करें, और A is NP hard. अगर A को मैं solve कर पाऊँ पॉलिनोमियल टाइम में, तो मैं क्लेम कर सकता हूँ ऐसे कि A can be reduced to be in polynomial time. Okay, got it. So, okay, we have Cook-Levin theorem is not very important, but you know, we could have some short answers on it. That K-sat is NP hard for K greater than equal to 3, right? Uh, okay. Okay, so input is Boolean formula in conjunctive normal form. Boolean formula in conjunctive normal form. Uh, this is a clause. Right. Task is to find assignment for the variables such that phi evaluates to true. Okay. We know SAT can be reduced to Hamiltonian path. There are some conjectures, right? One which is if P is not equal to NP, conjectures and their lower bounds. If P is not equal to NP, then no low polytime algorithm possible. Okay. You see, this is redundancy because we're doing this twice now. Exponential time hypothesis, X says that K-sat needs 2 dou to the power n time for dou greater than 0. And then there is the strong exponential time hypothesis, which says, which is SET for short, no faster algo than 2 to the power n, or there exists some epsilon which is greater than 0. For all epsilon greater than 0, there exists some k such that k sat cannot be solved faster than 2 to the power 1 minus epsilon times n. So upper bounds, okay. So sure, this makes sense to me. It makes a lot of sense to me. Okay. Seth says that brute force करना ही पड़ता है, ठीक है. Assuming Seth को OV से सॉल्व करने की कोशिश, तो Seth को ट्रांसफॉर्म करेंगे OV में. ये नेक्स्ट स्टेप करते हैं हम. इधर एक छोटा सा नोट मैं डाल दूंगा. K sat is 2 1 minus big O of 1 by k to the power n. 2 1 minus big O of 1 by n 1 by k to the power n, right? Which is perfect, I guess we get it. So we'll just get this reduction in place because this seems like a pretty decent reduction, because who knows, right? Reduction of k sat to OV, right? We know k sat का input क्या है? Variables, just clauses, right? So it's basically this. We are like k sat, and you get this phi, which x1 to some xn, and you're saying split every clause C into left and right clause C into CL and C right. CL uses x1 to xn by 2. CR uses xn by 2 plus 1 से लेके xn, right? And now for every assignment y of x1 x2 till xn by 2, it's either assignment is either going to be 0 or 1. This is going to be like an n by 2 vector. So we construct a vy which is a 0 1 vector of size d, and we say that, okay, you know what, vy is gonna be 0 if CL is true for y, 1 otherwise, and similarly for every assignment z of xn by 2 plus I to xn that belongs to a 0 1 set. Basically, like It's again going to be like a 0 1 thing. So you have like a UZ, which is going to be a vector which is composed of 0 and 1, which is going to be d-dimensional vector. And then you're like, okay, UZ is again 0 if CR is true for Z, 1 otherwise. Got it? This is how it's going to be. And similar, you end the algorithm by saying if OV if OV of U cross V equals true, return true, else return false. And in general, if I were to ask about the time complexity, I'll just be like time complexity of this thing. It's gonna be OV algo. We know OV algo is just 2 to the power 2 minus epsilon. Basically, that's how we do it. So it's just big O of 2 n by 2. So okay, so it's n squared. It's subquadratic, right? Like we say the OV's time complexity is n to the power 2 minus epsilon poly d. Now we know that uh, the the 2 minus epsilon thing remains the same, but the n changes because we have 2 to the power n by 2 vectors now, and the degree now becomes instead of d, it becomes n to the power k. I'll just say degree n in normal OV, right? And then we are like, for any constant k, this is big O of 2n times 1 minus epsilon by 2 poly n, which is less than big O of 2 to the power n 1 minus epsilon by 2, and violates set. Anyway, so we finished 19 by 10:04, which is pretty bad. I'll go to random practice, random again. Let's see. Okay. Finished making cheat sheet for PDF 19. Not good, honestly. Very, very bad, very bad. But let's just do this, right? Search and verify NP hardness KSAT definition and KSAT to OV reduction and time complexity. KSAT performance on conjectures, NP P not equals NP ETH and set, right? So that should be good enough. So this is 19 that we just finished. Oh, we closed 19 already. Look at us, look at us. So we closed 19 already, and we are moving on to debugging, decidability, and halting. Cool. So I'm just gonna make a section here called debugging, decidability, and halting. Debugging, decidability, and halting. Cool. So this okay, so let's see. Is algorithm A correct? If A is supposed to be implement function F, do we have A? Okay, so this is correctness. We're talking about the correctness of an algorithm. Okay, is there some input A or type error or okay, some can for is there some input where A seg false, type error or crash? Just try all inputs, return false if x seg false, x, but all inputs could be infinite. Okay, we cannot guarantee that A is correct. Interesting. We cannot guarantee that A is correct. Interesting. We guarantee an no algorithm can solve. Okay, no algo can solve the debugging task. Okay, so this could be in part of my flashcards, right? Choose what is debugging task? Check if an algorithm A is correct. Okay. True, false. There is an algorithm to solve the debugging task. There is an algorithm to solve the debugging task, and this is false. I'm just making a flashcard. No algorithm can solve the debugging task. We cannot guarantee that an algorithm A is correct. Cool. Which is interesting, right? Now there is something called the halting problem. What is the halting problem? So halting problem is input says algorithm A and input I. Output is yes or no. Does A on input I halt, or is there an infinite loop? We add this, okay? So input is algorithm A and input I. Yes or no, does AI halt, or there is an infinite loop? What is the halting theorem? Halting problem theorem. There is no algorithm that can solve the halting problem. Sure. True, false. Halting problem is decidable. False. Halting problem is undecidable. There is no algo that can solve the halting problem. Cool. So you can just be like, okay. No algo can solve the halting problem. It is undecidable. And there's some proof. You say halt. I don't care about the proof, honestly. I just want to do the Rice theorem. Right, let's just do the Rice's theorem. Rice's theorem is simple. Which says for any non-trivial output behavior P, for any non-trivial output behavior P, there is no algorithm that can check if an algorithm A has property behavior P. Okay, for any non-trivial output behaviors, behavior Okay.
So let's hear it from Rajesh. The question that I asked him is, tell me one of your favorite books that you have read.
So the book is called Anti-Fragile and is written by Nassim Nicholas Taleb. He's a very controversial guy, and the book Anti-Fragile.
What the Sigma? Skippity bro. Skippity bro. Okay. So Rice's theorem says that for any non-trivial output behavior, right? We gotta write the Rice theorem here. What does Rice's theorem says? Say that for any non-trivial fucking hell, bro. Okay. Let's see. For any non-trivial output behavior P, there's no algorithm can check. Okay. Got it. Okay. For any non-trivial output behavior P, there is no algorithm that can check if an algorithm A has behavior P. Okay. For any non-trivial behavior P, that can check if an if an algorithm A has behavior P. That's the Rice theorem. Even number, sec for returns x every. Okay. Okay. Okay, if it's only like dependent on input and output, okay. Must be an A that does not have B. Behavior defined okay. So has three things. There is an algorithm A with P, is an algorithm A without P. There is के जगह always must be an there must be an algorithm without P. P is defined with respect to input output. behavior is defined with respect to input or output. Okay, add. Cool. So for example, source code has length 1000 is not about input and output, it's the length of the source code. Given code of unexpected language Python, is there an input where A crashes because of type error? Non-trivial, right? Okay. There is an input where A crashes because of type error. Given a code does not have type error, okay, let property P and test. Okay, this is like complicated, but we don't need this shit at all. But let's see. Halt mi, decide if uh, mi will halt. You define a b, run mi, return ax. I know there's no real emphasis, so I'm gonna take a calculated bet on this maybe. So instead of doing this proof, I can just always use Rice theorem. I just want to use Rice theorem everywhere. So I'm going to take a calculated bet and I'm going to say that this proof thing is not going to come because there's just no real emphasis, and I think the problems would mirror closely those questions that were given in the assignment. So I'm going to say that I'm done with 20th also. Let's go here, girl. Okay. Finished going through PDF 20. Yeah, also added its content to the cheat sheet. Cool. Now let's see what's next. Okay, this is just randomized algorithms. Okay, randomized algorithms is the next next section. Okay, let's see. Your algorithm has access to random bits. So linearity of expectation and union bound, these are the two important parts of this algorithm. Okay, let's do one thing. Let's just pause. Let's just take like a 15-minute break and just chill out for a bit. We take a quick break because we know we got the entire night and breaks are important. Cool. Okay.
Received a blackmail attempt from a lawyer named Tony Busby, who was
Beautiful. Beautiful, beautiful, beautiful. Thank you. Thank you. Thank you. I needed this. Thank you. That's so good. Let's see what's up with Luigi. Why is there a squirrel girl trending, bro? Anyways, of course, this is a Luigi coin. That's crazy, dog. Well, his followers keep going up. I wonder what this means. Mm-hmm.
He was the best guy around.
What about the people he murdered?
What murder? He was the best guy.
Hmm. Nice, okay.
Isn't rational, it's physical. Mama, I'm in love with.
Damn, bro, people are just crazy. Not gonna lie, dog. Who is Ethel Kane, bro? Hmm. Hilarious, not gonna lie. People are crazy, dog. That's crazy, dog. Allegedly. Okay. Man, I'm procrastinating quite a lot. But anyways, life goes on. It's crazy, dog. Let me see if there are any viewers. Are there any viewers, dog? There are no viewers. That's life. In a way, that's good. Hmm. That's pretty interesting.
Release my nigga. Release.
Oh my god, dog. It's crazy, dog.
Mangione was just sitting there at a McDonald's with the gun that he supposedly used to pew pew the CEO. He was carrying a fake ID, and he was carrying a manifesto that supposedly said, "These parasites had it coming. I do apologize for any strife and trauma, but it had to be done." A little too on the nose, I have to say. There's just so much more to the story that's so peculiar. We have to get into it. First off, he comes from extraordinary wealth, one of the richest families in Maryland. It says Luigi Mangione, 26, comes from a powerful Maryland family centered around the late patriarch Nicholas Mangione, a first-generation American who built a real estate empire in that state that included country clubs and media. The family also owns a chain of nursing homes called Lorien Health Services. Reviews are, shall we say, not so great. Now, Luigi happened to volunteer there when he was in high school, which possibly could have been his first awakening into realizing just how rigged the healthcare system is in the United States. Also, it looks like he had some sort of back surgery at some point. Friends that went to school with him said what kept coming up was this back surgery that, quote, changed everything for him, and he went absolutely crazy. Not too crazy because he was valedictorian at his high school, at the prestigious Gilman School, an all-boys prep school that is known as one of Baltimore's toniest private schools. I had to look up what that meant. Apparently it means fashionable among wealthy or stylish people. And then he would go on to graduate from the University of Pennsylvania with both a bachelor's degree and a master's degree in computer science, learning about all kinds of stuff like AI, obviously a super smart guy, not a guy you would say was at his wit's end. Apparently also had a PhD. Wink, wink. Now, earlier this year, he left an Amazon review of the Unabomber Ted Kaczynski's book, Industrial Society and Its Future. He writes, when all other forms of communications fail, violence is necessary to survive. He was very active on social media. He was not shy about voicing his criticisms of the system, capitalism, corporate greed, psychology, philosophy, all kinds of stuff that he talked about. By the way, this account has now been taken down. But here's where things get odd. He stopped posting on social media altogether in June. This was his last post. It was a retweet of an Andrew Huberman podcast with Jonathan Haidt about smartphones and mental health, which leads me to believe that Luigi has been planning this for the last 6 months. CNN reported that posts addressed to the X account suggest that some of Mangione's friends had been trying to get in touch with him since earlier this year. In July, one user tweeted at Mangione, quote, "I haven't heard from you in months," urging him to respond to his wedding invitation. 3 months later, another user posted, "Hey, are you okay? Nobody's heard from you in months, and apparently your family is looking for you." So if nobody could find him, how did he get caught? Supposedly just sitting at a McDonald's, according to the police chief. Some people online are positing that this is just all too perfect, and they doubt whether this is even the guy.
It was actually crazy. Okay, I think I should. Damn, bro. Mm-hmm. Okay. Cool. Fair, I get it. Now, time to get back to our studies, I guess. I'm gonna go pee and refill my water real quick. I'll be right back. Just refilling my water bottle. I'll be right back. Come on, dog. Come on, dog. Stop using this, dog. Anyways, dost. We gotta keep hydrating ourselves, keep ourselves hydrated. That's what you gotta do. Oh. Oh damn! I spilled some water on my notes. That's bad. That's bad. That's sad, bro. Hey, hold on, dog. Hold on, dog. Why is suddenly? I see it now. Wow. There's no way that's him. Interesting.
Weapon possibly 3D printed with him, but no one, and I mean no one, is talking about the fact that the healthcare companies are single-handedly responsible for all of his family's wealth. I, however, happen to be just outside Baltimore, and in Maryland.
Okay. Nah, there's something fishy, dog. Nah, dog, that's crazy. Nah, dog, come on, dog. Nah, bullshit, dog. I call it bullshit. Nah, bullshit, dog. That's bullshit. Okay, cool. Very interesting, not gonna lie, dog. I get it. I get it.
बेस्ट है मेरे लिए, क्योंकि जो मैं पैसे कमा रहा हूँ उसी से मैं अपने दुश्मन को बलवान बना रहा हूँ। वही पैसे मेरे ही मुझे खुद को ही खत्म कर लेना बेस्ट है मेरे लिए, क्योंकि जो मैं पैसे कमा रहा हूँ उसी से मैं अपने दुश्मन को बलवान बना रहा हूँ। वही पैसे मुझे ही बर्बाद करने के लिए यूज हो रहे हैं, और ये साइकिल बढ़ता ही रहेगा, है ना। मेरे ही टैक्सेस के पैसे से ये कोर्ट, ये पुलिस सिस्टम मुझे और मेरी फैमिली को और बाकी लोगों को भी हैरास करेगा, जो अच्छे लोग हैं। तो जो सप्लाई है वैल्यू का, उसी को खत्म कर देना चाहिए। और एनीवे गेव मी अ सजेशन क्या दे टोल्ड मी टू कमिट सुसाइड, एंड आई थिंक दे आर राइट. That's the right solution, what they've suggested me. So I'm gonna take my life now. Also,
That's crazy, dog. That's crazy.
मेरी कुछ आखिरी इच्छाएं भी बताना चाहूंगा मैं.
What's going on here? Interesting. What's going on here, dog? That's crazy. Hold on. What's going on, dog? That's crazy. That's crazy. Hold on. What's going on, dog?
मेरा मानना है कि मुझे खुद को ही खत्म कर लेना बेस्ट है, मुझे ही बर्बाद करने के लिए यूज हो रहे हैं, और ये साइकिल बढ़ता ही रहेगा, है ना। मेरे ही टैक्सेस के पैसे से ये कोर्ट, ये पुलिस सिस्टम, तो जो सप्लाई है वैल्यू का, उसी को खत्म कर देना चाहिए। और एनीवे गेव मी अ सजेशन क्या दे टोल्ड मी टू कमिट सुसाइड, एंड आई थिंक दे आर टेक माय लाइफ नाउ. ऑल्सो मेरी कुछ आखिरी इच्छाएं भी बताना चाहूंगा मैं. तो मेरी कुछ आखिरी इच्छाएं जो हैं ये हैं, ज़्यादा मुझे उम्मीद तो नहीं है, लेकिन अभी भी मैं अपनी वाइफ को बोलूंगा कि उसमें तो कोई वैल्यू नहीं है, मेरी वाइफ में खुद। तो मेरे बच्चे को क्या ही बड़ा करेगी वैल्यू के साथ, मेरे पेरेंट्स को मेरा बच्चा दे दें, वो उसको बेटर वैल्यू के साथ बड़ा करेंगे। और आई थिंक शी शुड हैव डन इट विथ मी, शी शुड हैव गिवन द चाइल्ड टू मी, बट मुझे बच्चे से अलग रख के दुख पहुंचाने के लिए उसने किया है, जबकि उसे भी पता है वो बच्चे को रेज करने में अक्षम है। खुद ही बोली कि मैं बच्चे के पाल परवरिश के लिए पैसे भी नहीं है अगर तुम्हारे पास, तो हमें दे दो बच्चा, हमें, मेरा आखिरी अंश है, मेरे माँ बाप को दे दो, वो बहुत नाजों से पालेंगे उसे। और मेरा भाई एक बहुत अच्छा आदमी है, वो भी पालेगा उसे, बट मुझे ज्यादा उम्मीद नहीं है इसकी। दूसरा है, और मैं अपने माँ बाप और भाई को बोलूंगा कि बिना किसी कैमरे के मेरी पत्नी या उसकी माँ या उसके किसी भी फैमिली मेंबर से बिना कैमरा पब्लिक प्लेस के ना मिले। आप पर रेप केस भी लगाया जा सकता है, कोई भी केस लगाया जा सकता है, तो बहुत ध्यान से अगर किसी भी बात के लिए मिले तो पब्लिक प्लेस पे मिले। बाकी और औरतें होनी चाहिए हमारी तरफ से जो टेस्टिफाई कर सके कि कुछ गलत नहीं हुआ है, कैमरा होना चाहिए तभी मिले। दूसरा कि मेरी मेरे मरे हुए शरीर के आसपास मेरी पत्नी या उसका परिवार की तरफ से कोई नहीं आना चाहिए। तीसरा, मेरा अस्थि विसर्जन तब तक नहीं होना चाहिए जब तक मेरे हरासर्स को पनिशमेंट नहीं मिलता है, तो मेरा अस्थि विसर्जन ना हो। अगर इतने सारी चीजें, एविडेंस और सब कुछ होने के बाद भी अगर कोर्ट, ये जज और मेरे बाकी के हरासर्स को पनिशमेंट नहीं देती है और बरी कर देती है, तो मेरा जो अस्थि है वहीं कोर्ट के बाहर किसी गटर में बहा देना चाहिए, ताकि मैं ये जान जाऊं हमेशा हमेशा के लिए, मैं ये अपना लेसन सीखता रहूं कि इस देश में क्या वैल्यू है एक लाइफ की। तो ये एक है। और जुडिशियरी से मेरी एक दरख्वास्त है कि मेरे माँ बाप और भाई को इन फॉल्स केसेस में और हरास नहीं किया जाए, इसे खारिज किया जाए। और मेरे हरासर्स को और इस करप्ट जज को, और ये माधव का भी इन्वेस्टिगेशन होना चाहिए, है ना, ये भी लाखों रुपए कमाता है, तो जरूर पकड़ा पकड़ा जाएगा। बेसिक से कोई इन्वेस्टिगेशन करेगा तो कोई ना माधव पकड़ा जाएगा, उसके पास प्रॉपर्टीज होंगी, पैसा होगा, जज के पास प्रॉपर्टी पैसा होगा एक्स्ट्रा करप्शन का, तो वो पकड़े जरूर जाएंगे। अगर कोई कहता 50 रुपए तो ये हर कोई देता है, ये तो कोई ना कोई तो सामने आके बोलेगा कि 50 रुपए घूस लिया मैंने। तो ये तो सार्वजनिक बात है, अगर ये सब भी नहीं पकड़ पाते हैं तो फिर मेरी अस्थियां बहा दी जाएं गटर में कोर्ट के बाहर। तो ये मेरी कुछ अंतिम इच्छाएं हैं। इसी के साथ मैं ये वीडियो बंद करता हूँ। अब जो थोड़े बहुत जो मेरे आखिरी काम है कंप्लीट करके मैं मुक्ति पाना चाहूंगा इससे। मैं अपने मैं इस जज का कंप्लेंट सुप्रीम कोर्ट और हाई कोर्ट में भी मेल करने वाला हूँ। और मैं अपने माँ बाप भाई से अलग से उनसे बात करूंगा लिखकर। हो सके तो माफ करना, जिस उम्र में मुझे अपने मम्मी पापा का सहारा बनना था, उस उम्र में उन्हें हमेशा के लिए दुख देके जा रहा हूँ ऐसा, तो सॉरी। और बाकी आप लोग जो देख रहे हैं सब आपका कल्याण हो। थैंक यू।
That's crazy, dog. It's crazy. Yo, what's up? Okay, cool. Let's see. Keep studying, keep studying. Hmm. Mm-hmm. I don't get it, dog. I get it, I get it, I get it. Thank you. Yeah, thank you. That's nice. Interesting. Wait, what? I didn't know that. It's crazy. Hmm. That's true. That's hold on, bro.
I'm getting angry. It is wrong. Politely, this is. And for a came to your house to screw you. Bastards. Decency की हद है, indecency की. Whoever is this person, I don't want to see him in front. अगर तुम अपनी बाप की औलादों पे प्रूव कर दो ये पुराने 142 करोड़ इन्वेस्ट किए. अगर बाप की औलाद है तो. It's relevant to public domain. It's available in the public domain. Public domain है बोल रहा है थे. तेरी माँ की तू. कुत्ते की औलाद.
Okay.
No hood. This is serious now. A lot of people have been DMing me.
Hello, Mumsy. How are you doing?
Jake, go back. Change. No green jacket, no hood. This is serious now. A lot of people have been DMing me, messaging me. You have to go back and change. This is not funny. Are you listening to me? This is not a funny situation. Please listen to me. Jake. Oh my God.
What?
What don't you understand?
Oh my God.
It's
Let
a
him
federal
live.
crime. You need to go home and change. Do you
The
wanna
person that it was
have-
done to did a
Jake,
lot worse,
I
okay?
have 2
To
jackets.
the entire country.
I'm not negating.
What is this shit, dog?
Can be totally incredible. And the ones that have been life-changing for me have been ones where you like go travel to a guide and it's like very much psychedelic medicine. The like Burning Man version has been, I would say, less transformative.
The ones that are guided, how does that play into your work in AGI?
This was all like a long time ago. This was like during my off time, mostly. But I would say it was one of the most transformative things in my life. I think I used to be like a very anxious, unhappy person. And if
this now? Okay. Thank you, God.
Oh, Jesus.
So you have six.
Yeah.
Okay. Okay. Got it. Got it. Got it. Got it. Got it. I get it now. I get it, dog. Let's do this. Let's do these. Back from a fucking long break, dog. You know what? I'm just gonna keep doing this because I'm anyways running on fumes. Willpower wise, I just wanna. Oh my god, dog. It ain't easy, I tell you that. It ain't easy, dog. Interesting. No way, dude. This is okay. Is this real? Very interesting. Hmm.
Right. So I know this was back in 2000, around 2022. So you're coming out of COVID. I'm curious, RJ, did you know where he was working remotely or why he had suddenly decided to decamp to Honolulu? Was there sort of any break in his life or anything that you ever became aware of?
No. It's very natural. Our members all have remote jobs, and Hawaii is one of those places that many people would love to live. So we provide kind of an all-inclusive living experience, so it makes it easy for them to move to the islands.
Okay, so I know you considered him from your interactions with him, the time you spent together, as someone who would be a lifelong friend. What was he like when you knew him? And I know you shared some pictures with us as well. I mean, in terms of how social he was and the sort of interactions that he would have had with the other people in your co-living community.
He was a very thoughtful person, communicated really well, was friendly, had good relationships with everyone. He was even, in some ways, a bit of a leader. He helped spearhead a book club that we started just so we could, keep those intellectual pursuits alive from back when we were in school.
So you mentioned that he was into health. How did that manifest himself? And you mentioned you went hiking together, things like that. Can you tell us more about that? Why he cared about health? And I understand also that at one point you did become aware of some issues with his back.
Yeah, so when I first interviewed him before he moved in, I remember he said he had a back issue and he was hoping to get stronger in Hawaii. So he's always focused on trying. When he
Drop 60, drop it. Damn, bro. Dog, what the sigma, bro? That makes no sense. Honestly, that doesn't add up, bro. Nah, bro, that don't add up. Anyways. Fucking... Okay. Pretty painful, pretty annoying that I wasted time like this. I will not do this until I finish 1, 2, 3. What is fourth? My god, I have 4 things to cover, I guess. Anyways, dog. Anyways, let's see. So, randomized algorithms. Boy, come on, boy. Your algo has access to random bits, okay? That's the randomized algorithm. Okay? You have linearity of expectation, which says that the expected value of like 2 variables x plus y is just sum. Xy need not be x times y, sure. Plan time equals x plus x2. E time is just summation of x. Okay, that makes sense. Union bind for any 2 events A, B depending on some random variable x. The union is just less than equal to p a plus b. Got it? Suppose your algorithm has 2 functions or subroutines which fail with some probability less than some epsilon. Your algorithm fails with okay. with probability less than 2 twice of epsilon. Okay, that's just the union bound condition. Okay, and okay, we can just write this down, right? Probability of which just says, okay, and let me just make a flashcard out of this bad boy. ठीक है, linearity of expectations, t-ons, it just says that two random variables x, y, math bb of e times x plus y is just math bb of x, sorry, e x e of y, right? So just says that okay, this is x plus y is this, ठीक है, true false, true, linearity of expectations, true false again. I'm just gonna be like x dot y is not the same as expectation of x times expectation of y, right? False, this need not be true. Fair. Then the union bound says, defines a union bound, I'll say. It says for any two events a, b, depending on random variable x, probability of a union b, shit bro, okay, latex union symbol cup, okay, cup, what, cup, okay, is equal to a plus b, my god, it is less than equal to a plus b, okay. Is less than equal to, oh my god, this is like the wrong bracket, honestly, my bad bro. Hey, shut up dude. Nah dog, it's crazy dog. Okay, okay, define union bound. In general, hold on, wait, a1, a2, c dots, cup an is just less than equal to sum of I equals 0, I equals 0 to the power, okay, sorry, my bad dog, n pai. This is just in general the definition of union bound. I'll just add this motherfucker. Okay, suppose the suppose the algo uses two functions as subroutines. Suppose an algorithm uses two functions as subroutines which fail with probability epsilon. Okay, probability less than equal to epsilon, then your algo fails with probability dash, and the answer is 2 times epsilon less than equal to 2 times epsilon. ठीक है. We added 12 new cards to Grad Algos too, so we'll go to stats. We'll just see how many new cards we added. We added 12 new cards, which is pretty good, I guess. So let's just do that, right? 2 random x y. Cool. So we say expectation of x plus y is equal to expectation of x plus expectation of y. Note that this is not true. Expectation of x times y need not be expectation of x times expectation of y.